Thank you very much. Dear colleagues, I'm glad to see you. We have a workshop named Modeling Optimization and Controlling in Information and Technology System. We have an ability to talk to each other about our achievements. The first presentation is automate data mining of the reference stars from the astronomical CCD frames. Do we have the authors of this abstract?
Yep. Hello.
Hello. You may start your presentation.
Thank you. Let me share my screen. Do you see my screen?
Yes, we see your screen. We hear you, so you may start.
Great. So, good afternoon, dear participants of the conference. Today, authors present the paper called Automated Data Mining of the Reference Stars from Astronomical CCD Frames. Technological progress in the production of cameras and telescopes demonstrates continuous acceleration, reflecting modern trends in scientific and engineering developments. Today, digital cameras possess impressive characteristics, including resolutions exceeding 100 megapixels, significantly surpassing those of previous models. Telescopes are also keeping pace. For example, Pan-STARRS in Hawaii contains two telescopes with 1 and 8 meter aperture. Both are equipped with the largest CCD camera, which records about 1 and 4 billion pixels per image. Each such image requires about 2 gigabytes of storage, and exposure times will be up to 1 minute. So more than 10 terabytes of data are obtained every night. Also, the Large Synoptic Survey Telescope, LSST in Chile, currently is under construction. It will take image of the full sky every few nights. There will be about 200,000 uncompressed images per year that equals more than 2 petabytes. As the resolution of cameras and telescopes has increased over time, allowing for the registration and analysis of more detailed images of the night sky, this process directly impacts the ability to detect and study various objects in space. Some of them are solar system objects, variable stars, asteroids, comets, near-Earth objects, satellites, and others. The regular series of frames can contain hundreds of frames, where in one frame a lot of thousands of objects are presented. For scientific research and analysis, such big amount of data should be processed by the special data mining preprocessing methods and data reduction models, which simplify input by reducing unnecessary information. This means that we also have the data mining problems in astronomy. So how can we solve them? For the proper processing, we need to use all steps from the knowledge discovery in databases KDD process, which contains the data mining stage in it. So I want to tell you about the Lemur software of the collection light technology Kaleitech project. The Lemur software implements all data mining steps during processing the different types of astronomical information, which is fed online in automated mode. There are different types of data mining and KDD tasks, like discovery of the new objects, galaxies classes, identification of correlations, dependency, gravitational lenses, prediction of changes, and gamma ray bursts, and others. On this slide, you can see the results of frame processing by the Lemur software. There are raw frames on the left side and processed frames with alignment and centered view on the right side. Also, detected moved objects are presented on the right side. The processing pipeline of the Lemur software is presented on this slide. After intra-frame processing, the classification of measurements is performed. The different classes contain measurements of objects with null, near zero, normal, and very fast apparent motion. Data mining and processing of these sets of objects is performed in parallel. This approach reduces the execution time. During the intra-frame processing stage, there is an identification process with astronomical catalogs. This is called astrometric reduction. For astrometric reduction, at first we need to recognize pixels that are related only to the real object signal. Then software removes all unnecessary pixels from the input dataset to reduce the amount of measurements for processing. After the estimation of the object's position, the software starts frame identification with the stellar astronomical catalogs. This is a very difficult procedure because these catalogs contain more than billions of objects with appropriate information about them, including astrometric and photometric measurements. The main goal of this stage is to understand what part of the sky these frames are related to. For this purpose, we select the reference stars as a guide points in an image. Practice shows that the concentration of bright measurements in a certain area of CCD frame, for example in the center, can increase the identification accuracy in this area, but reduce it in other areas of the same CCD frame as shown in the left image. That's why, to ensure almost equal accuracy of object coordinate measurements throughout the entire CCD frame, it is advisable to distribute candidates for reference stars evenly throughout the frame. Therefore, it is necessary to fragment the frame into equal areas for uniform distribution of identified pairs when selecting candidates for reference stars. In each such frame fragment, the same number of objects with the bright measurements is selected. In this slide, you can see an algorithm for data mining of automated reference star selection. First step is a fragmentation of frame, then iterative calculation of the plate constants for the astrometric reduction, and the main step is appropriate rules for the rejection of candidates for the reference stars. Such rejection rules is developed for the proper excluding measurements of nearby objects from candidates for the reference stars in CCD frames, as well as the candidates in the catalog form for the identification. Another important criteria for rejection candidates is the absence of the brightness peak in the object's image in the CCD frame. On this slide, you can see details about our experiments. The series of frames were received from the different telescopes. More than 27,000 measurements were used for research. Also, the parameters for the developed methods are on slide. All of them were received empirically. The astronomical catalog USNO B1 was used as a photometrical catalog, which includes 3.6 billion measurements. As a result of experiment, you can see the histograms of distribution of the deviations by the equatorial coordinates measurements of reference stars. Right ascension on the left side and declination on the right side. On this slide, you can see the dependence of deviations of equatorial coordinates from the position of reference stars and from the brightness of object. Also, we calculated the different statistical indicators of the accuracy of reference stars measurements. They are average, root mean square, minimum and maximum deviations for both equatorial coordinates, R and D. The Kaleitech project is developed by enthusiasts. Kaleitech has assisted in making over 1,700 discoveries of asteroids, including 5 NEO, 21 Trojan asteroids of Jupiter, 1 Centaur. It has been used in about 800,000 observations, during which 5 comets were discovered. Thank you for your attention.
Thank you for the interesting presentation. Dear colleagues, do you have questions, please? Okay, so maybe I will ask you one or two questions. First of all, it is very interesting, but as I understand, the amount of data which you have to not only process but also store is very big. So, do you use some cloud technologies to operate those data?
Previously, astronomical catalogs includes a lot of lib files, like text files, with compressed information about each object, like about each reference stars. When we use measurements from CCD image directly, we use just RAM memory. We use just memory. So we are playing with our mathematical procedure inside memory without intermediate saving on storage at all. In the latest version of our Lemur software, we fully implemented client-server architecture, and now we are working with AWS cloud storage and S3 for storage, for file storage, S3. But we use it only for storing historical data and results of processing, but not again intermittent things.
Mhm. And another question is, it is great that you look at the sky far away, but what about the Earth ground? Do you try to use your methods to analyze the photos of Earth?
Yes, actually, we had a lot of experiments using the satellites frames and images. But again, the big difference between Earth and space, that on space we have like black and white images, and we know about magnitudes of each object that located in this area of sky, for example. And this information is already included in astrometrical and photometrical catalogs. Regarding Earth, we need to have like a map of reference objects, like high buildings or rivers on lakes, etc., just to understand how we can map the certain part of image with a certain place on Earth. And this is more complicated situation, so we plan to investigate it in future research.
Okay, I understand. Very interesting. Once more time, thank you. Dear colleagues, if you have no questions, we may start the next presentation. So, any questions? No, please stop the presentation.
Thank you.
Thank you. The next presentation is clustering technologies for modeling village infrastructure development. Do we have the authors of this presentation? Natalia Kasul, Богдан Потужный и Влад Свирш. Does anyone here from these authors? Okay, maybe they will be with us after some time. So the next presentation is redistribution of the compressed data between modified deflate block in the image compression process without losses. So do we have the
Yes,
presenters?
we have. Just give me a
Okay,
moment.
great.
I'm going to share my screen.
Start your presentation,
Yes,
please.
sure.
We see you, we hear you. It's great.
Okay. Okay, I need to edit my system preferences in the computer. Just give me a moment.
Now we don't see the presenter. But by the way, the next presentation after this, next presentation, information system for monitoring the planning maintenance. Do we have the presenters? Dear presenter, we see black screen, but don't hear anything.
Maybe if you don't mind, I can go next with my topic. I needed to edit my system preferences to be able to share the screen. So maybe we can return back to this topic of distribution of compressed data between the modified deflate blocks, if it's okay for you, for sure.
So you want to be next?
Yes, if it's possible, sure.
A few time to prepare. Okay, so the next presentation, information system for monitoring and planning maintenance of offshore wind farms. Do we have a presenter?
Okay, sounds like no, so maybe I can go.
You now have an ability to try?
Yes, I can now share the screen, sure.
Okay.
Okay.
That's great.
Can
We
you see my screen?
see your presentation.
Yes, that's great.
You may start.
Okay. Okay, dear colleagues, today we're going to present you research on the following topic: redistribution of the compressed data between modified deflate blocks in the lossless image compression process. Today, files transmitted by communication channels most often contain data of one of four main types: text, images, videos, and sound. And if 4 kilobytes is enough to store one page of unformatted text, the photorealistic raster image without compression can take several megabytes. Most of well-known algorithms that allow you to compress images dozens of times lead to slight loss of image quality. Such losses are invisible for photorealistic high-resolution images, but affect the quality of low-resolution images with fragments of business graphics or discrete tone transitions. Therefore, in the era of information civilization, when most of information is stored electronically, the problem of lossless image compression by reducing redundancy remains relevant now and will be relevant in the future. As it is known, any data compression is possible precisely due to the reduction or elimination of redundancies. Three main types of redundancies are distinguished in images: visual, inter-element or spatial, or quote, revealed when using quotes of the same length for items with different probabilities. To reduce redundancies of the second and third types in archivers or graphic formats, lossless compression of images most often occurs in a maximum of 4 stages. At the first stage, context-dependent coding reduces redundancies between the same fragments or fragments with the same structure. At the second stage, the transition to an alternative color model is performed. On the third, the brightness of pixels components in the transformed using predictors, which during image traversal predicts the brightness value of each component of the next, using the brightness values of the same components of the previously processed adjacent pixels. At the fourth stage, context-independent coding forms element codes, with lengths that depend on their probabilities. The main principle of context-independent coding is formulated as follows. The length of the code of an arbitrary element with a higher probability should not exceed the length of the code of any element with a lower probability. This principle is based on the fundamental position of information theory, according to which, in order to minimize the length of the sequence code, an element S with a probability of occurrence P should be coded with logarithm P bits. Then the average code length of the block element after applying any context-independent algorithm according to the formula of Shannon that you see on the screen can't be less than the entropy of the source. In practice today, two alternative context-independent methods are most often used, Huffman coding and arithmetic coding. Huffman coding matches each element depending on its fixed prefix code. Arithmetic compression is in contrast to Huffman coding, matches each successive element with an interval with a length of proportional to its probability. To speed up the development of the graphic formats, data compression formats are created, improved, and used, which combine proven context-independent and context-dependent algorithms. One of the successful examples of such combination is a deflate dictionary compression format, which for processing of incoming flow uses context-dependent LZ77 algorithm, and as a result of its work is compressed by Huffman's dynamic codes. According to the LZ77 algorithm, matching sequences of maximum lengths are searched in the dictionary from the right to left, because the same fragments of data are often found nearby. As a result, smaller offsets in the output stream occur more often than the larger ones, and therefore then coded in the deflate dictionary compression format with fewer bits. We use this compressed data format to develop a lossless progressive hierarchical image compression format, HBF-LS. The purpose of this article is to describe and justify the algorithm for a distribution of compressed data between modified deflate blocks to improve compression performance of this format. Let's investigate dependence of entropy for the case of two elements. If the probability of appearance of first element is equal to P, then the probability of the second element will be 1 minus P. We see that the entropy is maximal when the probability of the first element equal to probability of the second, and therefore the both equal to 0.5. The greater the probabilities of elements differ among themselves, that is, the greater unevenness of the distribution is, and the lower the entropy is. Therefore, to reduce the size of compressed data in the deflated format, it is advisable to implement the following options for a distribution of compressed data between its blocks. The first step is to combine two adjacent blocks of compressed data if the increase in the length of the entropy code from their combination doesn't exceed the same as from storing the header of the combined blocks instead of the two headers of the adjacent blocks. And the second, split blocks of compressed data into homogeneous blocks if it decreases the length of the entropy code from such a split exceeds the increase in the size of their header. Our algorithm, for testing our algorithm, we used the following set of the images. These images you can see on the screen. This is the international standard for testing of compression algorithm. This set contains both synthesized and photorealistic images. The choice of this particular test set is determined by the diversity of its images and the availability in the open sources of the results of testing algorithm by other researchers. Here there are results of applying of the suggested redistribution. From the data in the tables, we can see that application of redistribution of compressed data between modified deflate blocks made it possible to reduce the total size of compressed images of AST set by 3 kilobytes, although on average it slowed down the encoding by 6%. Moreover, a redistribution of this in the size of compressed image is observed both for photorealistic, like number 4, or for synthesized images like number 1 and 7. Other compressed images are hundreds of bytes smaller. Such modest results are explained by the fact that, firstly, the maximum gain from the combination of adjacent modified deployed blocks is equal to the block header, up to 380 bytes. And secondly, after using different scalar models and predictors, these images have a high uneven distribution of elements frequencies, and partitioning doesn't significantly increase their homogeneity. And thirdly, the data of different layers and passes of progressive hierarchical compression are stored in different compressed blocks by default. On the other hand, the redistribution of compressed data between deflated blocks made it possible to speed up decoding by an average of more than 2% due to discrete tone images, which indicates the feasibility of its use. Here are our conclusions. First, using compressed data formats which provide for their division into blocks, it's worth analyzing the expediency of combining adjacent blocks and dividing blocks into homogeneous fragments to reduce compression ratio before writing these blocks into a file. The combination of deflated blocks reduces the size of compressed data by a maximum of the size of the header of such block, and splitting increases the uneven distribution of the relative frequencies of the elements. So the sections should be implemented in image compression programs. The combination of deflated blocks of compressed data makes it possible to speed up decoding by reducing the number of generation intervals or costs of individual elements for such block. In the future, we plan to improve the mechanism of the lazy layout of LZ77 algorithm by memorizing and using smaller sets to shorten identical sequences that can be applied in the process of its formation. And to investigate the effectiveness of using the previous layout, this algorithm to predict the length of literals, lengths of substitutions, and offsets. Thank you for your attention.
I'm sorry, just a little bit technical problem. Thank you very much for your presentation. Dear colleagues, do you have any questions? No, so maybe I can ask one question or two. Dear Veronica, can you please tell us what is the closed analog for the method you propose?
So maybe, so we modified just give me a moment. Yep, so we modified the LZ77 dictionary algorithm with this redistribution of deflated blocks. So probably the answer will be LZ77 because it's the modification of this basic well-known compression algorithm.
Mm-hmm. And once more, any modification means that you specify the shorter area of use of your proposal than the analog one. So what is the area of apply your research you oriented?
Yep. So in general, so we can't say that it's that's a compressed area comparing with the basic algorithm for sure, because both algorithms are working to increase the compression ratio of the images. That's why, of course, we can apply both algorithms to different types of images. This concrete apply should be done mostly for photorealistic images based on our results of the testing. So yeah, but at the end, it's just, let's say, part of the algorithm that we're going to have in the end. So it can be applied to any images for sure.
Of course, which the necessary parameters that should be first found, as I understand. Thank you very much, Veronica.
Thank you.
Any other questions?
Thank you for your attention.
Any other questions? No questions. Thank you once more.
Okay.
Thank you very much.
Dear colleagues, Do we have a presenters for another presentation? Second presentation, once more, clustering technologies for modeling village infrastructure development. Do we have a presenter? No, we don't have a presenter. The next, information system for monitoring and planning maintenance of offshore wind farms. Do we have a presenter? No. Okay, a recommendation system based on a compact hybrid user model using fuzzy logic algorithms. Do we have a presenter?
Yeah, I'm here.
Great. So you may start your presentation.
Yeah, let me share my screen. Do you see my screen?
Yes, we see your presentation. We hear you, so you may start.
Yeah. First of all, good day, everyone. My name is Mikita, and I'm honored to be presenting to you today. As a contributor to the article titled Recommendation System Based on a Compact Hybrid User Model Using Fuzzy Logic Algorithms, I'm here to discuss our findings and how they can improve recommendation systems. Recommendation systems are essential for guiding users to relevant content in today's digital age. From streaming platforms to e-commerce websites, recommendation systems help users discover new movies, products, music, and more. However, traditional recommendation algorithms often struggle to capture the diverse and nuanced preferences of users. Enter Fuzzy Logic, a powerful tool that allows us to represent and analyze imprecise and uncertain information, providing a more accurate and personalized user experience. Now, let's dive into the heart of recommendation systems, the user model. Building an accurate user model is crucial for understanding user preferences and making relevant recommendations. In a hybrid user model, we combine data from various sources, including demographic information like age, gender, and profession, with behavioral data, such as past interactions and ratings. The hybrid approach allows us to create a comprehensive profile for each user, capturing both explicit and implicit preferences. To represent the diverse and nuanced preferences of users, we turn to fuzzy sets and membership functions. Unlike traditional crisp sets, which classify elements as either fully or in or out of a set, fuzzy sets allow for partial membership. This flexibility is essential for modeling subjective concepts like young or rich, where the boundaries are fuzzy. Membership functions assign a degree of membership to each element, allowing us to capture the uncertainty inherent in human preferences. In the hybrid user model, we combine crisp and fuzzy features to create a comprehensive representation of user preferences. For example, gender may be represented as a crisp feature, while age are modeled using fuzzy sets. By integrating data from multiple sources, we can create a more accurate and robust user model that captures the complexity of human preferences. This fuzzy hybrid approach is essential for building recommendation systems that cater to diverse user needs. Now let's explore how fuzzy distance metrics enhance the similarity computation process in recommendation systems. Traditional distance metrics struggle to compare user models with diverse and imprecise features. Fuzzy distance metrics address this challenge by considering the partial degree of membership in fuzzy sets. The fuzzy distance between two user models is calculated based on their membership values across different fuzzy sets. Yeah, sorry. Fuzzy user, sorry. The fuzzy distance between two user models is calculated based on their membership values across different fuzzy sets and allowing for a more nuanced compression. We need to compare two user models that have many vague features. So we need a local fuzzy distance metric that satisfies the following conditions. Zero value for the same feature values, zero value for different feature values in the same fuzzy set with the same membership values, the minimized distance between any two feature values belonging to the same fuzzy set having close membership values, and maximized distance between any two feature values belonging to two different fuzzy sets. Each user model has many fuzzy sets, so a local fuzzy distance should be found for each feature. The results of the given example show that the formula satisfies all four conditions of the required local fuzzy distance function. Accordingly, for the fuzzy approach, the fuzzy distance function between two users can be aggregated using a formula on the slide. Similarity computation. Similarity computation forms the backbone of recommendation systems, allowing us to identify users with similar preferences. By calculating similarity values between two user models, we can establish connections and form the set of neighbors for each active user. Fuzzy distance metrics play a critical role in this process, enabling us to compare user models accurately and effectively, even in the presence of diverse and precise features. With similarity values calculated, we can now select neighbors for the active user. The neighbor selection process involves identifying users whose preferences are most similar to the active users and forming a set of neighbors based on these similarities. By selecting relevant neighbors, we can ensure that the recommendations provided are tailored to the active user preferences, enhancing the overall user experience. In the experiment, we run the recommendation system using the developed algorithm and compare its results with classic methods, Pearson correlation and cosine measure. The system selects movies from the set of test ratings for the active user one by one. After that, it predicts a rating for them based on a set of neighbors who have rated the same movie. After receiving the predicted rating, the system compares them with the actual rating provided by active user. The slide shows the best and worst cases out of 5 possible ones. After analyzing the results of calculations, we can come to the conclusion that the mean absolute error of the developed algorithm is smaller, i.e. better compared to classic approaches, and shows that the deviation of predictions from the values of two ratings specified by active user has decreased. Coverage, the percentage of elements for which the recommender system can provide predictions remained at the same level and in some cases even increased. In all 5 runs, the percentage of correctly given ratings is higher for most users. This can be seen even in the 2 given graphs. In conclusion, fuzzy logic offers a powerful framework for enhancing recommendation systems accuracy and personalization. By incorporating fuzzy sets, membership functions, and fuzzy distance metrics, we can create more accurate and comprehensive user models, leading to more relevant and personalized recommendations. As recommendation systems continue to evolve, integrating fuzzy logic will be key to unlocking their full potential in providing users with the best possible experience. Thank you for your attention.
Thank you for your presentation. Dear colleagues, do you have any questions? No. So maybe I will ask you a few questions. First of all, you use fuzzy technology in your research. What is the main advantage of this technology in accordance to your topic of research?
It's advantage, for example, in cases when a person don't know explicitly, for example, he's young or he's adult, I don't know. For example, I am 25 years old and I don't know, I am considering me as young or as an adult. So in these cases, I think it can improve the recommendation because, for example, in my case, I want to see the movies both for young people and for an adult people, and maybe between these two sets of people. And I think the proposed algorithm can I don't know. It can recommend the movies, including these cases, which shows the fuzziness of user. I don't know to which class person classify himself.
Okay, thank you very much. And another question is regarding optimization. Fuzzy classifiers usually we can generate more rules than it is necessary, and the function of allowance of some object to one rule or another rule should be optimized. Do you use such technologies to improve the results of your classifier?
So as I show in my presentation, I use fuzzy sets not for all features. For example, I don't use this algorithm for the age, for the gender, because person can be can have one gender, I think, and but for the age, as I said, the person can be in different classes.
This
Partially.
is another thing. This is good that you put the features of that you took into account to another classes, class of fuzzy ones and not fuzzy ones. But fuzzy classifier optimization, it's a little bit another technology. So you may focus on this, and I think that if you will do that, the results of your research may be improved. For example, if not in the accuracy of the classification, but in the time that you spent on this process. Okay, thank you very much. Do you have any questions, dear colleagues? No. No. Okay. So we still have we still not hear two presentations, as I see. Значит, once more time, clustering technologies for modeling village infrastructure development and information system for monitoring and planning maintenance for offshore wind farms. We still not have the presenters for this research.
Good morning. It's me, presenter for information system about wind turbines, Maxim.
Oh, great. So you may start your presentation. Show us our presentation, please.
Yeah, let me share my screen. I'm sorry, I just joined recently. Yeah. Let me share my screen. Yeah, I need to relaunch Zoom. I'm sorry.
Дякуємо за організацію конференції. Це насправді дуже потрібна справа.
І вам дякуємо за присутність.
I'm sorry, technical issues.
Okay, we see your presentation.
Yeah, so
We hear you, so you may start your presentation, please.
So, good morning. Today is for your attention the presentation for article information system for monitoring and planning maintenance of wind offshore farms prepared by authors Victoria Vysotska, Kirill Smelyakov, Natalia Sharonova, Maxim Derensky, Rana Plechova, and Vadim Repikhov. So this work is devoted to the description of the key aspects of the development and use of a decision support information system related to the offshore wind turbines and maintenance organization. The main purpose of work is researching key aspects related to offshore wind turbines maintenance and decision support system development. And our tasks are the following. First of all is to analyze the current state of the issue in subject area, then make requirements for modern decision support system, then make a description of proposed information system, carrying out experiments with it, and give results of that experiments. And also make summary recommendations and some future plans on it. Nowadays, IT market segment dedicated to the development and use of decision support information system for a wide range and purposes is actively developing. Business and non-commercial organizations tend to reduce finances needed on operational work. This can be achieved by moving from paperwork to automated information systems and allow reducing cost and resources usage and optimize business and technological processes. The common examples are staff management systems, warehouse management systems, navigation systems, and variety of simulators and others. This work is the first step of developing the system that should optimize resource usage and reduce operational costs. The first task is researching how offshore wind turbine maintenance is performed. There were research related to the topic papers and made a conversation with specialists. The overall process is the following. Firstly, operator arranges inspections. He provides list of turbines that should be maintained, draft inspection teams and vessels. Then a vessel with inspection team and crew goes to turbines, where vessel crew chooses optimal path between turbines. Then inspection team inspects each turbine and reports about turbine state. The purpose of the developed information system is an automation of operators' work and decision support during maintenance organization process. Also, we should provide convenient visualization on user interface. And the use cases planned is managing entities such as ports, vessels, wind farms, turbines, and workers, maintenance organization, different maintenance cases modeling, and maintenance process visualization. According to the research results and formed requirements, there was developed the starting part of information system related to data entering and maintenance organization. It's based on web technologies and it's planned to be divided on 3 subsystems. The idea is that main factor that reduces operational cost is reducing not only operators' work, but also fuel consumption of vessels and building optimal path related and based on weather data. The focus of this work is on the turbine maintenance service that is responsible for entities, data management, and organization process. The backend API keeps data related to location of ports, wind farms, turbines, engineering workers, and allows to create inspections for turbine maintenance. The front-end application provides operator with a convenient user interface to interact with backend API and represents world map of sea surface and forms for entering data. The first experiment that was carried out is entering data. It's the starting point that after allows to create inspections. For that, operator place on map such entities as port, farm, turbine, create ships, and workers. As you can see in the picture, operator fills in needed information to form, and as a result can see data on the map. Operator can manage farms and edit and remove turbines and so on. The second experiment was maintenance organization. As you can see on the scheme, maintenance or inspection includes turbines that should be checked, ships or vessel that sends workers to turbines, and teams that perform maintenance. Each turbine has the status field based on which operator decides whether it should be included. Operator selects turbines, vessels, and form engineering teams. They will carry out several experiments on maintenance organization. The next is about our future plans on the system. Our future plans with which we are going to achieve the main object of research is to add weather data and optimal path planning. For this, we should gather data about weather from real-time data source, store it and keep it up to date. Based on this data, there will be optimal path planning to get the shortest path between port and farms by taking into account weather conditions. For example, storms should be avoided. That should reduce time in sea and fuel usage. So we obtained the following results. We entered the initial data. We created several inspections. The time of operator was reduced compared to paperwork, and inserted data was precise and adequate. So in summary, the main purpose of the information system is to automate most of the paperwork, reduce operators' effort and operational cost on turbines maintenance. Information system is easy to use and effective in its computation near to real equipment, and recommended to be used in learning systems to allow operators and service personnel to learn and gain practice. In conclusions, we solved such tasks as analyzing of current state of issue. We made requirements for the modern decision support information system. We described proposed information system, made initial experiments with it, and gave the interpretation. And we did summary and recommendations. So thank you for your attention.
Thank you very much for your presentation. Dear colleagues, any questions? Okay, so maybe I ask you a few questions. Tell us, please, what about the data security? You work with the data that describe the industrial objects, and if you don't pay attention on the data security and you control something, you may have problems. So what about this option?
Yes, thank you for the question. Yes, the security question is it's a significant question. Yeah, related to engineering data, we should keep there in some secure place. For example, it's planned to be internal system. So this information system can be deployed to some server that also secured with security connection, for example, HTTPS. Also, it can be supplied with some authorization systems where where operators can be registered in advance and only have their credentials to actually authorize in that system. And also we can have different types of operators and people who have different different rules of how to which page and which functionality they can use. So yeah, that should be also taken into account. And yeah, actually, the only thing is secure connection and registered operators in advance. Yeah.
Thank you. And another option is that you use the data regarding the weather. But there are a lot of investigation which focused on the predicting and analyze the weather. Do you use those models in your research, or you don't use this data? If this data is information, if no, then why?
So currently we are in progress with gathering weather data, and like we are in progress with testing of two approaches. First approach is to just get data from some open source APIs of weather data. That should be like the most easier way, because they can provide weather data by different times of day. Also, they can provide weather data on 7 days further, and you can request data by coordinates or by area and get already formed weather data. But also we can use some models that can predict weather based on some statistic data or on artificial intelligence models. So actually, yeah, we are in
Okay,
progress of
so this
testing
is the
both
plan
of
for your
them.
future research.
Yeah,
Thank you
it's
very
like
much.
a second part of this.
Thank you very much. Any other questions, colleagues? No. Then thank you once more time. You may stop your presentation.
Thank you very much.
Okay, so as I understand, the only presentation that we still not hear is clustering technologies for modeling village infrastructure development. And do we have the presenter? Still, we not have a presenter, but maybe this presentation was made yesterday in oral. I heard that there was some changes in this regard. So, as I understand, all other presentation we heard, and that's why I think that we may stop the work of our session. I think that we work great. The poll presentation was interesting. We have a discussion. We have plans for future research, and I hope that we realize all our plans, and we will get a new plans for the future. Not only that we describe now, because the life is very interesting, and when you're working, you will always find some other interesting things that were interesting to investigate. So I hope that we will realize all our plans. Do you have any other things to say to us, dear colleagues? No. Then once more time, thank you. So we may stop the recording of our. Thank you. We are starting the second part of our section. Modeling, optimization, and controlling in the information and technology system workshop. So we have an auditory. So let's start from our program. The first research named Data Security Analysis in EMM Systems. We are ready to hear you. Does anyone ready to present this research?
I think Konstantin
Yes,
started,
sorry.
yeah, but was
Yes.
muted, yeah.
I forget to enable my microphone. Sorry.
Okay,
so,
okay.
Yes, let me show my screen. I'm sorry, I need to reconnect because of system
Okay,
problems.
I understand you.
1 second, please.
Maybe we can start from the second research, not waiting for reconnection. Second research, the title of which is using probabilistic dynamics in innovation and to manage the recovery and
Костя, как всегда.
modernization of Ukrainian industries. Does anyone want to present
Не
this
смог
research?
подключиться. Нормально?
Что?
Костя.
Какой Костя? Does anyone ready to present second research? Okay, I see that we have the ability. I think we have an ability to listen to the first research.
Yes. Let me.
Yes,
did
we
you
see your
my
screen. Okay.
Okay.
Start your presentation, please.
So, good day, everyone. I'm Konstantin Necholat. And today I'm going to present to you our work, data security analysis in enterprise mobility management systems, from Olga Cherednichenko, Irina Kirichenko, Konstantin Nechvolod, Kirill Smilyakov, and Alexander Dolkhanenko. In today's increasingly mobile world, the security of corporate information on personal devices is a significant concern of organizations. The rise of enterprise mobility management systems aims to address the concerns by providing a robust framework for the secure use of mobile devices within the corporate environment. The concept of bring your own device, or BYOD, has transformed the way businesses operate. This trend, which allows employees to use their personal devices for work-related tasks, has significantly enhanced productivity and mobility. However, it also presents new challenges in terms of securing corporate information. As we delve into this topic, we will explore the importance of IT policy that addresses the security risk associated with BYOD. BYOD gained significant traction in 2009 following its adoption by Intel. The initiative saw a dramatic increase in the use of personal devices at work. This shift underscores the urgent need for robust security measures to safeguard corporate data against breaches and cyber attacks. From a security perspective, the implications of using BYOD are extremely serious, as the lack of a proper policy regulating the use of personal mobile devices at the workplace exposes both the user and the company to the risk of data breaches and cyber attacks. This policy should specify ways of using mobile devices outside the workplace, accepted mechanism for access protection, data encryption, access to data on mobile platform, restrictions on running applications that can operate outside the company's boundaries, email client or data processing programs, etc. The main component in addressing these challenges is mobile device management, or MDM. It's a suite of technologies and services designed to secure and manage mobile devices within an organization. MDM aims to protect corporate information on devices outside the network infrastructure and monitor the device status, ensuring both security and compliance. Let me talk about fragmentation of Android. As number of devices which have various versions of running Android OS is very big, it's necessary to create some cloud-based services to improve current security level. The count of Android versions is described in the current slide. Also, devices running the Android operating system have strong security foundations. A number of cloud services support Android devices to further enhance and ensure the overall security of the platform. Google Mobile Services, or GMS, is a suite of applications licensed to Google by third-party software manufacturers and Android partners that allows you to easily control the pre-installation of applications such as Gmail, Maps, Photos, YouTube, etc. Any GMS licensed device also has device-based software scanning and cloud-based security tools, namely a core set of services and features called Google Play Protect. This range from on-device scanning for potentially dangerous apps and app exploits to Find My Device, to locate lost or stolen devices and detect routing. This slide shows how we can secure our data, our sensitive data. So we have the main operating system, and we have a protected application container, which we can use only when we know security keys, for example. And one of standout solution in this space is Samsung Knox, a platform that offers unparalleled protection by creating a secure environment through hardware-based security and policy management. This system establishes a root of trust, builds trust during a system boot up, maintains device security through real-time protection, and verifies its integrity through device attestation. During the execution of the work, a software implementation was developed to block the possibility of using the device camera in any application. A camera was chosen as an example because only a small number of permissions are available for free, and the camera is one of the most suitable for demonstrating the functionality of the Knox system. The program is implemented in Java and XML programming languages using Android SDK and Knox SDK. So the description of the logical structure. The user asks to grant permission for the app to work. The user must activate the application as a device administrator. Then the user must request a license, and after that, the user can disable or enable the camera functionality. As user, I mean system administrator or security administrator in the company. So examples of this result program are shown on the current slide. You can see a toast message in here, which say to us that our security policy denied to use camera. So, however, despite the advanced security features offered by platforms like Knox, there are challenges. The diversity of operating systems and device fragmentation complicates the management and standardization of EMM systems. Nonetheless, these platforms provide essential tools for IT and security administrators, enabling them to integrate mobile devices securely into business infrastructures and manage software development. In conclusion, the proliferation of mobile devices in the corporate sector necessitates the adoption of EMM systems to ensure data security. Systems like Samsung Knox represent a significant advancement in mitigating the risk associated with BYOD policies. Despite the challenges of managing diverse devices and operating systems, the development of such system is critical for securing corporate data in the era of mobile computing. Thank you for your attention, and look forward for any questions or discussions on this topic.
Thank you for interesting presentation. Dear colleagues, do you have any question, please? Okay, maybe I will start, and after that we will have some questions. First of all, it is a very interesting presentation because it depends on information security. This stream of research is very wild, not wild, but wide. So can you please tell us more clearly what is the highlights of your research?
Okay. In this research, I tried to explain the problem of using the personal devices like phones, tablets, laptops, or something like that for any work reason. So in company which I work, we have such problem. So we made a research that showed us that this is a very big problem. So first of all, when we have our company like infrastructure which are securely hosted on some buildings, for example, it is clearly how to secure some sensitive data. But when what we will do when our employees should go outside and spend some and send some data to our local system, so we could give their devices and make some policies, install some software, and then we can be sure that their connecting with our system is all secure. We can be sure that even if their phone, for example, will be stolen, we can remotely remove our sensitive data, or we can remote block any access to this data. So, and as experiment, I try to show how to manage some policies. In my case, it's disabling camera. For example, our security policies in our company deny using camera at all, and we can disable it in this personal devices. So something like that.
Thank you. Dear colleagues, do you have any questions? No. So, thank you once more time. You may stop your presentation, and
Thank
we
you.
are moving to the next presentation. Maybe someone of the authors team are here. The second presentation on the program is using probabilistic dynamics of innovation to manage the recovery and modernization of Ukrainian industries. Do we have any presenter? No. Okay. The next presentation is holistic adaptive optimization technologies for distributed data streaming systems. Do we have a presenter?
Yes, we have.
That's great. So you may start your presentation.
Okay, let me share my screen. I hope I'm audible. So
Yes, we see you, we hear you. You may start.
great. So hi everyone, my name is Vadim Demchuk, and today I'd like to present a publication on the topic holistic adaptive optimization techniques for distributed data streaming systems. The authors are Victoria Vysotskaya, Irina Kirichenko, Vadim Demchuk, and Irina Grusdon. So the purpose of this study is to analyze the existing approaches of performance tuning and identify their strengths and weaknesses, to provide a comprehensive approach that overcomes the existing challenges, conduct an experiment, and evaluate the results. Before we start, let's dive deeper into the big data world. So streaming has become a crucial part across different industries, such as IT monitoring, business, for instance, personalization, fraud detection, and science. So the trend underscores that the number of streaming data pipelines is constantly increasing. That's obvious because data needs to be handled on the fly to gather insights immediately. But what are the challenges of streaming? So the first challenge is once the application is deployed to production, the data flow is growing. It means that sources produces more data. Consequently, the streaming engines, the streaming systems have to adjust the throughput by scaling horizontally to meet the expected performance. And once the limit is reached, this system starts to throttling, performance and throughput goes down, latencies increase. And obviously, performance needs to be tuned at this part. So data engineers dive into logs, into metrics, try to play with the parameters to improve system performance. And this is like process of error and trial. And such improvement can be significant, more than like 50%, only by changing the configuration. And the second challenge is that such data pipelines are built using different technologies and tools. And due to the huge variety of the tools, it's pretty hard to apply some best practices. Of course, it also requires from data engineer to have a strong technical background to turn to such performance. So what are the existing approaches? This topic is well covered in the mentioned articles. I like to highlight ML approach and automated. In both cases, we leverage data, we leverage parameters of processing engine using ML module, and automated apply changes on the fly. The disadvantage of the drawback of these approaches is that they don't take into account properties of the source, of the targets, their configurations, their metrics. What is a performance tuning? If you consider a data pipeline, it consists of the properties of the input data, of the targets, resources available, configuration set of all the parts, and our task is to find optimal parameters when system will show higher metrics. So we consider in the following metrics, and they are widespread in the big data world. So input rate and processing rate, the difference is input rate, how fast data arrives to the system, processing rate, how fast processing engine is able to process, and processing rate, if this one is lower than this one, then the system falls behind. This metric shows the sizes of the input batches of the input data frame. Batch duration, it tells the time that takes to establish connection to the source and to wait the success, the result from the target. While operation duration is a subset of batch, it means that it shows time that took to transform the data. Okay. So, and to address the existing challenges, we have introduced the holistic adaptive optimization technique. It consists of connections to all the parts of the whole entire data pipeline. This helps us to gather logs and metrics into data collection service. Then with the help of ML module, we gather insights. And these insights are applied to the whole entire data pipeline using the control module. Then for the experiment, we, from the technology stack perspective, we chose the most popular one, such as Kovtun Kafka. This is cloud management version of open source Kafka, Apache Databricks. It has better performance and more parameters for tuning in comparison to the open source. And data lake is like a kind of a standard in big data. And here you can see the parameters that were chosen for performance tuning. For Kovtun Kafka, we used only partitions of the input Kafka topic, the number of partitions. Then, okay, what are the most important one? This tells the size of the batch, controls the size of the batch. Means Spark partitions defines how many consumers we will create for reading Kafka. Kafka partitions and other parameters. Then we used a huge data frame of 80 million records that was processed on a cluster of more than 180 gigabytes of RAM. As the result, so we've conducted a couple experiments. And at the first stage, the ML model in both cases of based, so this is existing approach, it performed only for the processing engine itself, and it modified only sequence shuffle partitions and sparse memory fraction. While HLT considered properties of the source and targets, modified, for instance, mean partitions. So it means that each Kafka partition will be read by in parallel by 4 consumers. Also, it found a correlation between mean partition and shuffle partition. This is basically best practice in case if the size of input, like batch, is relatively small. And the results were very promising. So although the batch duration and operation duration showed lower results, the processing rate and input rate was significantly increased. We can see that total execution time was like almost 40% faster. It means that we process the same data set by 40% faster in comparison to the existing approach. So in conclusion, the holistic adaptive optimization technique has the following benefits. First of all, it adjusts configurations of the entire data pipeline. It means that the streaming system reacts on the changes in the source stream, in the targets. It ensures that optimization are applied in the whole, in the all parts of the data pipeline, starting from the sources, ending with the sinks. And the last but most the important one, that this approach doesn't require human intervention. It means that businesses can save time of experienced data engineer because this kind of optimization is applied automatically. Well, that's pretty much it. Thank you for your attention, and I'm looking forward for your questions.
Thank you. Dear colleagues, questions, please. Okay, maybe I will have some questions and ask you. You told us about optimization. It is very interesting, and you showed us some mathematical models, but I don't hear regarding the classification of this optimization problem. So can you please classify this optimization problem? What method do you use to solve it, and what is advantages and disadvantages of this method?
Okay, thank you for your question. So let me go back. Oh, sorry.
Yes, this is it.
So in the mentioned articles, I used the following optimization approach. So I only extended it for the case that we analyze also sources and sinks. And the most important part that here we apply. So we analyzed application logs and metrics, and using linear regression, we defined optimal metrics that provided us that has given us better options for the data pipeline.
It is very good to use line model because you can find the solution of such an optimization problem, which no problem. For example, those simplex method easily give you an ability to solve any line optimization problem. But the problem is that even here we see the word pipeline. That means that I'm sure that some of data, some parameters that you use are not non-linear in the real life. So this, I think, this case you should investigate in future research more clearly. Because the line optimization is good for the first to understand the perspective of the research, but after that you need to go deeper. This, at my opinion.
That's a good point. Thank you for your comment. Yeah, of course we will consider another approaches to measure such metrics.
Thank you very much. Any other questions, dear colleagues? No. Then please turn on your presentation, or turn off your presentation, and next research named automatic prevention of the vessel's parametric rolling on the wave. Do we have a presenter?
Yes, we have presentation.
Okay, start your presentation, please.
Good day, colleagues. The authors of the Pearson State Maritime Academy will offer you a report on the topic automatic prevention of the vessel parametric rolling on the wave. stormy sailing conditions are one of the most difficult conditions on the road. The situation worsens also due to the fact that during a storm, such dangerous phenomena as harmonic and parametric resonance occur. Parametric resonance is one of the most dangerous phenomena. An intact and properly loaded vessel can capsize within seconds. The aim of the work is to develop method automatic avoidance of parametric resonance. This will allow automating ship control processes, reducing the influence of the human factor, reducing decision-making time and risks of ship and cargo loss, as well as improving the safety of shipping as a whole. The causes of parametric resonance is the coincidence the change period vessel's metacentric height with the period of forced oscillation in the roll channel. The differential equation of the angular motion of the vessel in the roll channel can be written in the form 1, where Ix is the axial inertia moment in roll channel, lambda 44 is the inertia moment of the attached mass of water, Mx is the damping moment, Mx theta is the restoring moment, and Mxt is the moment of external influences of wind, current, and turbulence. Omega x is the angular rate in the roll channel, and theta is the roll angle. The linearized equation 1 will have the form 2. Taking into account that omega x is the first derivative of the roll angle theta, and the angular acceleration is in the roll channel is the second derivative of the roll angle theta, equation 2 will be rewritten in the form 3. After entering the markings, the differential equation 3 will take the form 4. The occurrence of parametric resonance is relative to harmonic change of the parameter omega 0 squared, represented by the formula 5. Considering all this, equation 4 can be rewritten in the form 8. The component delta mx theta multiply sinus omega t in equation 8 in the cause of parametric resonance. Figure 1 shows the result of modeling the differential equation 8 for mx equals 0. As can be seen from figure 1, even in the absence of external influences, mx equals 0, a harmonic change in the component delta mx theta multiply sinus omega t of the restoring moment can lead to swaying of the roll angle, and this is parametric resonance. The condition for a current parametric resonance is coincidence forced oscillation period T with natural oscillation period Tc of the vessel in the roll channel. It is parametric resonance first type, or coincidence forced oscillation period Te with half natural oscillation period of the vessel. It is parametric resonance second type. Period of forced oscillation can be written in the form 10. Taking into account formula 10, system 9 can be rewritten in the form 11. Equation 11 determines the areas of parametric resonance first and second type. In figure 2, shows the areas of parametric resonance for the period of the vessel's natural oscillation 20.5 seconds and the wavelength lambda equal 90 meters. As can be seen from the given diagram, the areas of parametric resonance lay along axis V sinus Q. The most dangerous options is to remove the phase point A along the resonance zone by combined maneuver, speed vector VH3. When maneuvering the course, speed vector VH2, the phase point A move along the circle depicted by the dashed line. In this case, the time the phase point stays in the resonance zone is significantly reduced. The optimal speed maneuver, speed vector VH1, is when the phase point moves along the axis V cosinus Q and is removed from the resonance zone by the shortest patch. Second, workability and effectiveness method of automatic parametric resonance prevention are verified by mathematical modeling in the MATLAB environment. The first experiment, initial parameters of the vessel and wave movement correspond to the point A of the parametric resonance area, figure 2. Ship course is 0 degree, ship speed is 2.5 meter per second, wave course is 180 degree, wave speed is 11.9 meter per second. Control system maintains the vessel's initial course and speed. Simulation results are shown in figure 3. As can be seen from these results, period of forced oscillation is about 6-7 seconds, which can be seen from the period of the vertical speed oscillation Vz, draft T, trim angular rate omega y, and trim angle psi. Period of oscillation in the roll channel is about 12.5 seconds, which coincides with the period of the vessel's free oscillation in the roll channel and is twice period of forced oscillation. In combination with a significant amplitude, about 50 degrees, this indicates the presence of parametric resonance of the second type. Second experiment. As in the first experiment, initial parameters of the vessel movement and the wave correspond to the point A of the parametric resonance area, figure 2. Ship course is 0 degree, ship speed is 20.5 meters per second, wave course is 180 degree, wave speed is 11.9 meters per second. Control system constantly monitors the condition for the occurrence of parametric resonance. Simulation results are shown in figure 4. As can be seen from the given result, starting from the time 0 second, control system reduces the speed of movement. This is explained by the fact that initial position of phase point A is in the area of parametric resonance. And to avoid its development, the control system automatically calculated the safe speed and course, which are 20.1 meters per second and course is 0 degree, and began to reduce the speed to the calculated safe value. At the same time, the control system maintains a safe course with accuracy 2 degree. Results also show that during the decrease in speed, increase the amplitude of oscillation in roll channel is observed, which reached about 40 degrees by time 60 seconds. After this time, increase in oscillation amplitude stops, and starting from time 100 seconds, oscillation amplitude in the roll channel sharply decreases to the value of forced oscillation, which indicates exit from the parametric resonance area. Analysis of given result shows that control system allows to automatically calculate the safe parameter of the vessel movement and support them when the phase point I deriving from the parametric resonance area. And result. A method of automatic parametric resonance avoidance has been developed. Developed method can be used for both manual and automatic control. In the manual control mode, shipmaster can the opportunity to use automatically measured information and the result of its processing, visualization of parametric resonance areas and position of the phase point for making control decision. In automatic control mode, system itself calculates and implements safe movement parameters, and shipmaster only observes its operation. Obtained results are reproducible and can be used to develop a function of automated systems and automatic parametric resonance avoidance modules. The theoretical significance of the obtained result lies in the development method of automatic parametric resonance avoidance. The practical significance of the obtained result lies in the possibility of applying the method for developing modules for automatic avoidance of parametric resonance, automatic control processes, reducing the influence of the human factor on control processes, reducing the delay in making management decision, reducing the risk of ship and cargo loss, improving shipping safety in general. And thank you for your attention. Please don't hear you, Viacheslav.
I'm sorry. Thank you for interesting presentation. Please, do you have any questions, dear colleagues?
I have a question.
Please.
Please return on the slide number 8. Okay, thank you. On this slide, you displayed a certain area in which the parametric resonance activation zone is observed. Why are the right and left red vertical lines not symmetrical? And why are they removed from the center at different distance?
Thank you for your question. The slide shows the areas of parametric resonance of the first left and second right types. The different location and size of these areas on the diagram is explained by the fact that these dangerous phenomena occur for different parameters of the ship's movement and waves.
Okay, it's maybe can used where in the fact danger is about etc. Yes.
Yes, of course.
Okay.
Yes, thank you for your question.
It's clear. Thank you a lot.
Okay, maybe I have one little question. Can you please tell us more clearly what are limitations of using your methods? Because as I saw at the expression 10, there is a control parameter in the in this in the low part of this expression. So it means that at some situation you will not have your model will not give you an output. Maybe you take this into account or not?
Thank you. Stormy sailing conditions are the most difficult on the road. They lead to an increase in mistake in the control of the ship, exhaustion of the crew, increase the risk of loss of the ship and cargo. In our presentation, proposed a method for automatic and optimizing storming processes through the use of the onboard computer in the control system and finding safe and optimal parameters of the ship's movement through conditional optimization in onboard computer.
Okay, thank you. Thank you for your answer. Dear colleagues, any other questions?
I have a little question.
Please.
In a stormy sailing condition, the only question is the survival of the ships and cargo. In your presentation, you also talk about control optimization. Tell me, please, did I understand you correctly?
Thank you. The work uses the conditional optimization method of the fmin-con MATLAB type, which allows to determine a safe and optimal movement parameters, the ship's course and speed, in the presence of the inequalities types restrictions. These restrictions identify dangerous areas and navigation hazards. The method of conditional optimization is only a numerical means of determining the safe and parameters of the ship's movement. For its work, it is also necessary to form a target function and a system of restriction that define dangerous areas to process measured information and evaluate unmeasurable parameters to organize maintenance of safe and optimal movement parameters by the control systems.
Okay, thank you.
It's all.
Understand.
Thank you for your question.
Other questions, dear colleagues? No questions. Okay, thank you one more time. Please turn off your presentation. And the next research named algorithmization of intellectual data analysis for measuring the country's innovation potential. Do we have a presenter?
Yeah, we have.
Okay, start your presentation, please. We see you.
Good afternoon, dear participants of the conference. I would like to thank the organizer for the opportunity to present our study at the difficult time of Ukraine. We want to present you a report algorithmization of intellectual data analysis for measuring the country innovation potential. The authors of the study are Hlipko Sergey, Natalia Vnukova, Olena Peredri, Vasil Pivovarov, Natalia Peshka, and I, Davidenko Daria. Today, I and my colleague Natalia Opeshka will be the main speaker. Since everyone had the opportunity to familiarize themselves with our publication and report, we wanted to provide a brief description of the work and want those present with the result of the study. The article presents the key principles of using applied intelligent system in the economic analysis of Ukraine's innovation potential, which significantly improves the processes of management algorithms construction, and as a result creates a favorable environment for innovative development. It presents an algorithm for measuring the country's innovation potential, which is based on basic method applies for the analysis, distribution, and classification of input data space. The advantages of applying the principal component method are identified along with the procedure for using it to determine key indicators for assessing the country's innovating potential. An approach to determining innovation potential is formed based on intelligent data processing, allowing for the analyzing and visualization of large volumes of data, as well as identification of trends, key factors, and indicators influencing innovation activity in Ukraine. The research also justifies the feasibility and purposes and approach to using modern intelligent system for continuous monitoring and control of the level of innovation activity, as well as for identifying and forecasting risk and issue, and determining possible ways to address them. That's all. Thank you for your attention. Maybe you have a question? Colleague?
Thank you. Thank you for the presentation. It is short but informative. Dear colleagues, do you have questions? Okay, maybe I have a few questions. Tell us, please, what features do you take into account when you describe the innovation?
Yes, Viacheslav, thank you for your question. I will help to answer it. Yes, so regarding the features which have been taken into account for this resource, first of all, our goal was to create methodology, to analyze the innovation potential of the Ukraine. So we divided in several steps. First of all, we identify the key parameters which could be used for analyzing the innovation potential. For this, we analyze different literature resources, and afterwards, in order to eliminate from the analysis indicators which have high correlation between each other, we created correlation matrix and which allow us to remove from the analysis indicators which have high correlation between each other. And if the correlation factor is more than 30%, we just remove it. Afterwards, our goal was to optimize these indicators, and they create the base for the further analysis, which to find that indicators which can show the whole picture. And afterwards, we use factor analysis methods of principal components, and to create the indicator, the one and only factor indicator to analyze innovation potential. We also use taxonomical analysis, and afterwards we divided this indicator into the level
low, significant, average, and high, and it's help us to show the dynamics of innovation potential of Ukraine, and afterwards it will help us to modeling, to find the management actions for each of the period, and to understand the root causes and possible actions. So it was like a brief description of features, actions, and steps of the analysis.
Thank you very much.
Mhm.
Thank you very much. We hear almost all that you use almost all features that are usually used when we talk about data analysis and some statistic analysis. Maybe only one aspect is that some of parameters of your model may be but yes, are fuzzy or not.
Yeah, probably.
Okay. That
Yes.
means that you may focus your future research on, for example, neurofuzzy mathematical apparatus and compare the results. Thank you very much for interesting
Thank you.
presentation.
Comment. Yeah. Thank
Maybe
you.
someone else can have a questions. No. So please turn off your presentation. Dear colleagues, we still not hear one research. As I remember, the using probabilistic dynamics of innovation in the manage of the recovery and modernization of Ukrainian industries. Do we now have a presenter or not?
Автори цієї доповіді з Харкова, вони казали, що не знають, чи вдасться підключитися. Якщо ні, просили поставити їхній запис. На жаль, мене зараз заблокувало, я не можу зайти на YouTube, щоб включити їхній запис.
I think that this is not a problem because we have such a record and we will be able to watch this presentation in Facebook, as I know about specifics of the organization of Collins conference. So thank you for the information. That means that we will not wait for this presentation. So all the research that are present in the second part of our workshops was presented. Thank you, dear colleagues. But in the first part of our research, we also didn't hear one presentation. As I remembered, clustering technologies for modeling village infrastructure development. Maybe the authors of this presentation or this research are here or not? So they also not here. So that means that our workshops comes to the end. Thank you very much, dear colleagues, for your participation, for your presentation, for your questions. And I hope that this experience is good for us, and we will use those knowledges that we get during this workshop in our future work. Have a nice day and good luck.
Thank you so much.
Thank you so much. Have a good one. Bye.
Yeah. Bye-bye.
Goodbye. Goodbye, dear colleagues.